Now in this video, I have a 5-volt DC source in series with a switch. Across the front of my DC source, a 200 ohm resistor in parallel with a 300 ohm resistor and a 100 microfarad capacitor. Now at this time my switch is open, which means that there's absolutely nothing happening in my circuit. Now I will close my switch. As soon as I close my switch, I will have 5 volts here. And I will also have 0 volts across my capacitor. And at T much greater than 0, my voltage across my resistor, my 200 ohm resistor, will still be 5 volts. But my voltage across my capacitor will now be 5 volts and I will have 0 volts across my 300 ohm resistor. This state is called the steady state. Now, after I close my switch, the capacitor begins to charge. And this is the formula for the charging capacitor. BC equals 5 volts times 1 minus e to the negative t over RC. Now I will find my RC. RC equals 100 microfarads times 300 ohms. That equals 100 microfarads times 300 ohms. That equals 30 milliseconds. And this is the time it takes for the capacitor to charge up to 63.2% of the total voltage of 5 volts. And now I'll open my switch. Now, after I open my switch, my capacitor will begin to discharge through my 300 ohm resistor and through my 200 ohm resistor. And notice that for a very brief moment, after I open my switch, I still have 5 volts here, 0 volts here, 5 volts here. And the formula for the discharging capacitor VC equals 5 volts times e to the minus t over RC, and RC equals 100 microfarads times 300 plus 200, 300 ohms plus 200 ohms, that equals 100 microfarads times 500 ohms, and that gives you a time of 50 milliseconds. That's the time it takes my capacitor to charge down to 36.8% of the total voltage of 5 volts. And after a long time, and after t much greater than 0, I have 0 volts here, 0 volts here, and I've got 0 volts across my capacitor. And this brings me to the end of the video. Subscribe, like, share. Subscribe, like, share. Thanks for your attention.